Hi guys, Mr. Janowski back again. Here we are on chapter 35 study guide, problem number 7. This is one of those weird ones where you've got a couple of loops and your job is to figure out what's the current going through each of the resistors and what is the magnitude of the current going through each of the resistors. So here's my second crack at using this Wacom tablet. Hopefully it goes a little bit better than the first one, but no promises. We'll see what we do. So let me get rid of this guy. Come on. All right. All right, so here's our circuit. Your first job is to name the currents you've got coming out of here. So I'm going to say the current leaving this battery and going this way. I want to call this one I1. Seems like a good name for it. And right away I know that the current, if that's the current going out of this battery, I'm still trying to use this thing like a trackpad, and that's not how a Wacom tablet works. I swear I'll get the hang of it. So the current, if you have I1 coming out of the battery, you must also have I1 going into the battery. So I also know this one down here. Yep. I1. All right. And then right at this point, we come to a junction, and we've got to figure out what to do. So the current's going to split here. So part of it's going to go this way, around here like this, and back this way. And the other part is just going to leave straight down through here. So we've got to name these things. You can name them whatever you want. Lots of things will work. Again, I'm going to be consistent the way I do it. I like to call this one here I2. Could just as easily have called the other one I2, but I'm calling this one I2. Which means the current coming through here, you could call it I3. That is one way to do it. I believe a much better way to do it is to apply KCL, Kirchhoff's current law, and say that this must be I1 minus I2. Boop. So that's the current coming through here, down here, and back through here. Again, this must be I1 minus I2 because of KCL. If you have I1 coming into this junction, you must have a total of I1 leaving this junction. So, look at the math. If you have I2 coming down here, then the part that's left must be I1 minus I2. So that's how it works. That's not the only way to name your currents, but that's what I'm going with. All right. Next step, name your loops. So I like to start bottom left, go counterclockwise, and I want to call this loop A. And over here, what we got? Start bottom left, and that's clockwise. That's not counterclockwise. I know how a clock works. Call that one loop B. Not the only way to do your loops, but that's how I like to do it, so that's what I'm going with. All right, so now you've got to make two different equations. So we'll start with the equation for loop A. My writing still looks terrible. I swear I'll get better at it. All right, got real laggy. I don't know why that is. All right, whatever. So yeah, loop A, what do we have? Well, look back at the circuit. Your loop starts here. First thing it gets to is V1. So is V1 going to be a drop or a gain? Think about it for a second. You're going from the negative terminal to the positive terminal of a battery. Therefore, this is going to be a gain. So over here, I'm going to write V1, plus V1. Next, we get to R1. So is R1 going to be a drop or a gain? Well, my loop is going the same way as the current I1. Therefore, this has to be a drop. Remember, if your loop is going through a resistor with the current, that gives you a drop. So remember V equals IR. It actually makes more sense when you're doing these, though, to write V equals R1, I1. All right. Still very bad with the Wacom. I'll get better. Then what's our loop do? Comes to that junction, comes down here. So now we're going through R3. We're going through R3 in the same direction that we guessed I2 is going. Therefore, this is also a drop. So minus R3, I2. And then where do we go from here? We go back down here and nothing happens and we're back to the beginning. All right, so remember KVL tells us the total gains and drops all the way around any closed loop has to equal 0. So that's what we have here. So now go in, put in your numbers. V1, 18. It's really 18 volts, but I'm leaving that off because that's how you do these problems. Minus R1, I1. Well, R1 is 15 ohms. So I'm going to write minus 15 I1. Then we get to minus R3, I2. Well, R3 is 25 ohms. So minus 25 I2. This equals 0. All right, and then clean this up a little bit. So I'm going to subtract 18 from both sides, get my terms in the order I want them. So minus 15 I1 minus 25 I2 is equal to minus 18. And then I'll just leave it like that for now. Could multiply everything by minus 1, but we'll see what we need to do with the equation after that. So now I need another color. Get all these wonderful colors. I don't know what any of them are. Should have been more artistic. Let's pick a nice purple one. Violet. Violet looks nice. Still trying to use this thing as a trackpad. All right. So for loop B, what's going on? You start at the bottom left, you come up here, and we get to R3. So is this a gain or a drop? Well, my loop is going clockwise, and it's going against the current I2 that I drew. So if you go through a resistor against the current, that actually ends up being a gain. So that gives us plus R3. All right, and let's just remember that's a plus. Plus R3 I2. And then we come up here. So we get to R2, and our loop is going the same way as this current, I1 minus I2. So this will be a drop. So minus R2 times I1 minus I2. Really thought this Wacom would be easier to use. All right, I don't know why my computer's getting laggy. That's not helping matters. So there we go. I drew it. There it is. All right. So yeah, that's what happens there. That's what happens there. That's what happens there. The loop comes down through here. We get to the battery V2. So is this a gain or a drop? Well, our loop is going through this battery from the positive terminal to the negative terminal. When that happens, it's actually a drop. So minus V2. And then the last thing is we come down here and our loop goes through resistor R4 and it's going in the same direction as the current. So if you go through a resistor, if your loop goes through a resistor with the current, that gives you a drop. So remember your rules for doing all this stuff. So minus R4 times, and the current we have here is I1 minus I2. All right, and then we get back to the beginning. So KVL tells us this must give us 0. All right, so now let's put in the numbers. R3, so R3 is 25 times I2 minus R2 is also 25 times this quantity, I1 minus I2. Minus V2. V2 is 9 volts, so I'm just writing 9. Minus R4, which is 35 times I1 minus I2, and all this has got to equal 0. All right. Nope. Trying to make more room. Come on now. Okay. Sorry that took a while. All right, so what do we have here? Do all the algebra. There's a lot of small math going on here, so I'm just going to rewrite. Oh. 25 I2 minus, all right, distribute this carefully. So minus 25 I1, and then minus 25 times minus I2 is actually going to give us plus 25 I2. Minus 9, so minus 35 I1, and then minus 35 times minus I2 will give us plus 35 I2, and this equals 0. All right, so again, there's a lot of small math going on here. You got to be careful what you're doing. So one little tip is go in and underline all the terms you're going to deal with first. So we're going to deal with the I1s first. So minus 25 I1, minus 35 I1, and that's all of our I1 terms. So that's going to give us minus 60 I1. And then, all right, let's use double underline for the other ones. So there's an I2, there's an I2 term, and there's an I2 term. So 25 I2 plus 25 I2 gives us 50 I2, plus another 35 I2 gives us plus 85 I2. And then the last thing, don't forget about this guy, is we had a minus 9. I'm going to add 9 to both sides to get him on the other side. So there's our other equation. So the two equations we have are this one right here. You know what? No, I'm not going to circle it. It'll just make it more confusing. I've got this equation right here and this equation right here. So what I need to do is, I've got a system of equations. So I've got to do something to eliminate one of my unknowns. Let's go back to blue. I like ultramarine. So what can I do to these two equations that will make elimination easier? I'm going to end up multiplying this guy up here. Multiply the whole thing by minus 4. All right, so if I do that, that's going to end up giving me 60 I1 plus 100 I2, and then minus 4 times minus 18 is going to give us 72. All right, so why did I multiply everything by minus 4? Because when I grab this guy over here, I'm just going to write him right underneath. So line up your terms. That's a 60, not a 66. So minus 60 I1 plus 85 I2, and this is equal to 9. So if I just add this straight down, what's going to happen is all of my I1 terms go away. Over here, I'm going to have, come on, that looks terrible. I'm hitting undo. All right, do it with the keyboard. All right, I'm going to have 185 I2, and then this is equal to 81. So next, you divide both sides by 185, and that's going to give you I2 is equal to 0.4378. 0.4378, and the units are amps. This is a current. All right, so let me circle this. Let me circle this nicer. All right, visual artists out there, the first time you ever used a Wacom tablet, did you do better than me? Probably yes. So yeah, now I have I2. So I went from having two equations with two unknowns to I made one equation with one unknown. I solved for it. So where do I go from here? I'm going to sub this idea back into any of the other equations. So let me go with, actually the one I went with on my sheet was, I had this one. 15I1 plus 25I2. And remember, we just decided I2 is 0.4378 amps. Is equal to 18. So where did I get that from? That is just this equation times -1. All right. So you do this. This is going to give you 15I1 plus 10.9459. And this is still equal to 18. So subtract this guy from both sides. 15I1 is equal to 7.054. Divide both sides by 15. And you end up with I1 is equal to 0.4703. And the units are amps. And there's absolutely no reason for this to be in parentheses, but I started it there, so now we're stuck. All right. So I've got the other one. So we should figure out one more thing at this point. And that other thing is, what is I1 minus I2? So that's just going to be equal to 0.4703 amps minus 0.4378 amps. And that's going to give us I1 minus I2 is equal to a very small current, 0.0325 amps. All right. So I'll circle this. This is something else we needed. Sorry to be circling so slowly, but again, not good at this stuff yet. So now I know my three currents. So let's go back up here to this chart. It still does not work exactly how I thought it would. Okay, stop. Sorry, I'm new at this, and my computer's being laggy for some reason. Come on, there you go. All right, that'll do. All right, so what currents are what? The current going through R1, well, look at your picture. That current is just I1. And your value for I1, 0.4703. That's a 0.3 amps, okay? And what's going through R2? Well, what's going through R2 is I1 minus I2. So if I were better at this, I would scroll down and show you the number, but I'm not. So I'm just going to write down the number. 0.0325 amps. Come on. So what's going through R3? Well, R3 is just I2. I2, remember, 0.4378 amps. And R4, what current is that? That's the same current that's going through R2. That's I1 minus I2. So that is also 0.0325 amps. So we're almost done. Notice we did this and all of the currents we ended up getting were positive. That means all of the arrows we drew here were in the right direction. So we just need to look at this drawing carefully and figure that out. So through R1, well, our guess was right. I1 is going this way. So that means the current through R1 is left to right. All right, what's going through R2? R2 is right here. That's I1 minus I2. That is also going left to right. Now R3 is here. We have I2 going there, and we guessed the direction correctly. So it is going top to bottom. And our last one, R4. Again, we guessed correctly. So this one's going right to left. So there we have it. Hopefully that helps. Again, quick review. What you do is from the beginning is first you guess, you name your currents. You guess which way they're going and you name them. Try to come up with as few a number of currents as you can. So I called this one I1, this one I2, and then instead of calling this one I3, I applied KCL and came up with I1 minus I2. That way I only had two unknowns, so I only needed to write two equations. That's not the only way to do these problems, but I think it's the best. I'd rather solve a system of two equations than solve a system of three equations. So yeah, first I drew my currents, then I went in, I drew my loops. I always like to start bottom left and go clockwise. Call this one A, this one B. I used my loops to create two separate equations. So I followed this loop around, did all my rules for gains and drops, came up with this, put in my numbers, came up with this. I went around loop B. Same idea over here. Gains and drops all the way around. So gain, drop, drop, and drop. Got another equation. So then I had a system of equations. I used elimination to solve for them, figured out what everything was, went back and did it. So I feel like this video is getting kind of long. Hopefully this helps.